is Ron from the Encyclopedia team. It is with great pleasure today we have Dr. Rashid Al-Yahyai to this interview. Thank you very much for joining us.
Thank you. It's a pleasure.
So, Dr. Al-Yahyai, before we dive into your research topic, please tell us a little bit about yourself.
Well, I am Rashid. I did my PhD at the University of Florida in the United States in the field of horticultural sciences. And I also did my master's in the same area, as well as had a minor from Cornell University in international agricultural development. I did my bachelor degree back home in Oman. I am from Oman, a country in the Middle East, for those of you who don't know where Oman is. My bachelor is actually in plant sciences. And I still, since I graduated, I was employed by the department in 1993. Until today, I'm still working there as a professor of horticulture at the Department of Plant Sciences in the College of Agricultural and Marine Sciences. So I'm still there. But currently this year, I am on sabbatical leave as a visiting scholar at the University of Reading in the UK. So I'm speaking to you from the UK, even though my affiliation is Sultan Qaboos University in Oman. And I studied in the US. So I have a very nice combination of very different systems of learning.
Fantastic. So you have traveled from places to places.
Yes, and I had the pleasure to visit almost every country in Asia as well for conferences and meetings.
Oh,
so
nice.
I was actually lucky. Now we are getting a little bit more restrictions on travel, like not used to be the way, but I have very good team to work with in different countries. And I was, I'm happy also to supervise students, postgraduate students in different countries as well.
For sure.
So I look at the whole globe as my own village back home where I grew up.
Fantastic. So could you please tell us a little bit more background on biotic plant stress?
Yes, actually, my work itself is within the overall theme of food security, just ensuring that everybody gets adequate nutrition, adequate food supplies. And this is part of the global development goals, as you already know. And we all working towards as publishers, as scientists, as researchers. So within this theme, there are challenges and we have issues. Primary issue I work with is plant production and also the limitations of plant production at the field level, as well as trying to save also food at the other end, which is reducing food waste and food loss. So I also work on post-harvest. I've been working on post-harvest for quite a long time. So these are the two sides, production and also increasing production, as well as reducing losses and waste and food waste as well. In the production side, the challenges are primarily, especially from our side of the world, like where I come from, Oman, which is a very hot country. And so the challenges there is these kind of stresses. Abiotic stresses include high heat, drought, we don't get enough water. The rainfall in my country, in my part, is an arid country. So it receives less than 100 millimeters of rain every year. That's very little, considering the number of growing population over there. As well as the other kind of stress, like salinity, which is driven by our dependence on irrigation due to the drought. But in recent years, we had extreme weather conditions driven by climate change as well. And this has a very devastating effect on the food production sector in agriculture in particular, especially cyclones. We are not used to cyclones. Now we have seen in the past, like 50 years, more than 15 cyclones, tremendous damage caused by these cyclones. And this is driven by climate change. So the concept of abiotic stress is no longer confined to drought or heat. It is a compound effect, multiple effects or factors of climatic and especially climatic conditions that are driven mainly by climate change. And this is what I am doing actually right here in the United Kingdom, because as you know, climate is not just one country, like my country, Oman. It's not about a particular drought event. It is a global phenomenon that is causing so much destruction in the production side of food. So we can work on both food waste and food loss, but also the challenge is tremendous in the production side.
So you mentioned the food difficulty in your home country. Is that what makes you want to research biotic plant stress? Did you get any influence from other people too?
Exactly. That's the main driver because for a long time, I came from a country where oil is the major, income or revenue for a country. Before oil, and this was only recently, like less than 70 years. Before that, the reliance was on agriculture and fisheries. And so people have used agricultural practices for centuries before we reach to the oil. And now we are able to secure our food through imports mainly. But still, this time when disruption of the supply chain can happen at any time, your own supply is very important. Closing that food gap is also very important. And so that's why me and my team are interested in closing that gap, either by increasing food production or reducing waste and loss of food, post-production. And so within that theme, we work on stress mainly because in our part of the world, that's the main challenge, basically. Water stress, heat stress, all kinds of disease stress too, biotic, not only abiotic, but also biotic stresses, pests and diseases. Believe it or not, many of the pests and diseases originate from our part of the world, like witch's broom disease of Lyme, for example. You would not expect a disease to come from an area that is actually cannot be classified as agricultural region, but that's where some of these pests come. So even though pests and diseases, invasive species are also problems, but they all linked to the production side for fruit production. You cannot have fruit production just by tackling only one aspect of it, but you have to also look at all the challenges, and not only locally, but also on a global scale as well. Because the world now is not just it used to be, my own village, cultivating my own crop of date palms, I have my own livestock. Not anymore. It's not that way. Anything that happens in one part of the world, whether it is on plants or animals or humans even, like we witness in COVID-19, can also have implications throughout the whole world. And so independent, multidisciplinary, multi-country work is now more in demand more than ever. So that's what makes me interested in multidisciplinary research. I work a lot on different aspects of food production, not just one abiotic stress or drought stress, because I don't see that as only one just the solution. Solution has to be compounded. Multiple inputs from different countries, from different parts of the world. We all can do this together, and we can all tackle it, and we can achieve those goals that the world set for itself, the Millennium Digital Development Goals that we are striving for: zero hunger, climate, and environment. These are very, very particular and very critical for all of us. Yes.
We sure hope there is no hunger in the world soon. So, what is the interesting part about your research? Is there any limitation?
The most interesting part, it is evolving. It changes all the time because every time you tackle an issue, a new issue comes up. And the good thing is the number of tools that we have at our disposal nowadays. We have the technology that we didn't have a few years ago. We used to look at physiological processes at just merely respiration, photosynthesis, not anymore. This is a very minute biochemical processes within a part of a cell, not even a cell. And so that we can manipulate. We have nanotechnology. We have the advanced SNPs in molecular biology that we can identify certain aspects of a plant characteristics that we can utilize to tackle what? Tackle biotic and abiotic stresses, produce more food through these techniques. So that's what makes it interesting. What makes it interesting also the number of people you work with. Every day your circle of friends expands, your circle of collaborators expands. Every time you publish, you get new contacts, new people are interested in your work, they cite your work, and that circle of collaborator ever expanding in different areas too. So it is actually evolving, and it's not boring anymore. It used to be boring. You just do everything every day. You go out to the field, do the same thing. Not anymore. It is very exciting, the number of advancement and the level of technology that we have at our disposal right now. So as a scientist, we need to work not just with scientists, but also with the community, with growers, farmers, for example, with the processor, those people who are utilizing digital imaging for computer vision technology, for example, to sort out the good from the bad, the infected from the non-infected. So we reduce the risk or biosecurity risk to crops in other countries. All of this makes it interesting and exciting. So I'm extremely excited about the advancement in science and technology related to my own research projects and research work. Yes, that's how it is.
Speaking of scientist community, what you just said reminds me of a saying, it's the friend you made along the way that makes the journey good, right?
Exactly, that's what it is. And you got to enjoy the journey itself before you get to the destination. You are going to get eventually to the destination. There will be hurdles and issues, but you have to enjoy the journey, and you have to bring along friends, colleagues, students, community members of the community. It goes to the level of the individual household. Education needs to go all over, not just in schools or universities, but also all over the community. And people are very supportive and understanding of the value of research, because they rely on it for all the advancement of human being. And so it's our job as scientists and people who work in academia or people in the field of science in general, wherever they are, to bring along all these people, educate them, to show them the new technology, how it is best used. It's not just about commerce or finance. It's just about the education of the community to bring along this journey, this wonderful journey of science and exploration. And so it makes it so far more interesting than just wearing your lab coat, sitting in the lab from 8 to 5. Instead, no, go out there, go to the growers in the field, go to the household at home, explore, and you'll be able to see wonderful things. Actually, you'll see solutions to your own problems. And that's how research evolves, when it involves so many people in the journey of research and exploration. I agree with you, totally true.
So our next question is, will further research be needed in this field? And is there a next move for this research from you? And what are your main interests in your following research?
Yes, very nice, very good question. Thank you for that. Would it be needed? As we advance in technology, and especially artificial intelligence, we think we rely less on humans, but not in the biological sciences field. You could probably do that in other fields, especially fields of technology and the field of agent physics, math, processing of huge amount of information and data. Biology is not a linear way of life. It's not just 1 + 1 = 2. This is not how it is. And so you will always be needing humans, whether they grow the crops in the field, identifying issues. You can be assisted with technology, but you cannot, this kind of job related to human nutrition and food, whether it is production side or consumption side, cannot be substituted with technology. Technology can assist you in identifying issues, reach certain solutions to problems, but they cannot be a replacement of our involvement as scientists. So it's really important that we continue to strive to do better, to collaborate, to identify issues and problems and solve them. You cannot be sticking to your own line of research for a long time, because everything is evolving. If you are not evolving with technology, if you are not evolving with the change over time, and now the change happens in a very short time. What we produce in science now, the whole humanity has not produced for millennia. So science is accelerating, and as scientists, as researchers, as problem solvers in the field of science, we need to also keep up with this information. If you don't keep up, you will be obsolete. And that's indeed what will happen. They will not be needed. People who lag behind will not be needed, but people who are active, forward thinking, active, in their field, also proactive in their field, not just active. These are the ones who will always reach there, and they will provide solution to humanities. And I believe strongly that it's in our hand to do that. But lagging behind is not going to help. Lagging behind technology is not going to help. It will make you obsolete and unneeded, unnecessary for research or for science or for community. What's the point of someone who's now working on a system that has been already done 10 years ago? Your flash drive is no longer the same. Like if you look at your capacity of your flash drive today, I compare that to 5 years ago only, the maximum is totally different. Why would you be different? Your capacity as a researcher should also be expanded, just like a flash drive. So that's how we better sustain ourselves, continue to strive for research, and people will support you. Financial organization that support you financially, they will, if you prove that you are useful and providing solutions that to actual problems that are current, that are right now needed, then you will be supported. But if you are lagging behind, working on essentially old issues that are no longer relevant to humanity, you will not sustain your research. You will just be dead, basically, in terms of science production and value as well. So your value is nowadays with you keeping up with the current changes, problems, and providing solutions to humanities right now. You cannot be stuck with your PhD research 30, 40 years ago. It needs to be today's problems that you are tackling in order for you to be active and you'll be supported. But I don't think ever science will ever, not be supported. It will not be substituted by technology, especially again in biological sciences.
Those are some really inspirational quotes you have just said. So last but not least, is there any acknowledgement you would like to make?
Yes, sure. I acknowledge you first for giving me this opportunity. It's very nice of you. And also MDPI, the whole team has been working very hard to put the science out there for the whole world to actually learn. And we are working together in this area. So my acknowledgement to all my colleagues in Oman, here in the UK, and also my professors in the US, and my postgraduate students and the grad students in particular. I believe I work hard to make sure that once I'm gone from my area, there will be a new generation that will take over with the same inspiration, the same energy, the same proactive mentality to solve world issues and not just localize it. Look at the greater good of humanity. So I'm thankful for all of those who supported me. Of course, I'm thankful to my family, also my wife and my friends. All of them are very supportive, and I appreciate everyone without naming anyone, so I don't have issues later on. People are saying they did not mention me. I'm thankful to all of them. And also, thank you again for this opportunity. It's been wonderful talking to you.
Thank you again for joining us, and we wish you and your team the best luck for your future endeavors and research.
Thank you. I appreciate it. Good luck to you too. Thank you.
You.